A bold warning about impending danger in low Earth orbit. A new study suggests near misses in space are becoming routine, and the odds of a serious collision could be higher than many plots of sci-fi dramas would have you believe. Recently, a Chinese spacecraft came within about 655 feet, 200 meters, of a Starlink satellite, narrowly avoiding a crash. The research, which is not yet peer-reviewed, argues that such close calls are increasingly common in low Earth orbit, and the risk of a major collision is alarmingly high. What the study says. The researchers base their conclusions on the current count of objects in low Earth orbit, LEO, as of last June. They propose a troubling scenario: if collision avoidance systems were suddenly lost or if operators faced a severe drop in situational awareness, a catastrophic collision could occur in roughly 2.8 days. Such a collision could spark a large debris-creating event, potentially triggering the early stages of Kessler syndrome. In that scenario, debris from numerous past and future collisions could cascade, filling many orbits with fragments and making it harder to deploy or operate satellites. While Kessler syndrome would unfold over decades, the initial disruption would be immediate and painful for our space infrastructure. A growing hazard in crowded orbits. The authors emphasize that the risk isn't just theoretical. They point to a dramatic increase in objects in LEO, rising from about 13,700 in 2019 to nearly 24,200 in 2025. They estimate that satellites across all LEO megaconstellations now pass within 0.6 miles, 1 kilometer, of each other roughly every 22 seconds, creating ample opportunities for collisions. Starlink, the largest and most exposed. Starlink remains the most extensive LEO megaconstellation, with around 9,300 active satellites that form the backbone of the current network. Harvard astronomer Jonathan McDowell notes that Starlink makes up the majority of active Earth-orbiting objects, and the number of Starlinks is still growing as SpaceX continues to launch new units each year. Collision avoidance activity in Starlink. In the densest regions of Starlink's deployment, satellites experience a close approach event, within 0.6 miles, about every 11 minutes. On average, each Starlink satellite conducts around 41 collision avoidance maneuvers per year, which equates to roughly one maneuver every 1.8 minutes across the entire Starlink fleet. A troubling trend in maneuvers. The study notes that the frequency of Starlink's collision avoidance maneuvers has been doubling roughly every 6 months, highlighting how quickly the risk profile is changing as the constellation grows. Two plausible disruptions threaten avoidance capabilities. Losing the ability to perform avoidance maneuvers, or experiencing a significant drop in situational awareness, could, in theory, precipitate a catastrophe. The researchers identify two scenarios that could disrupt avoidance: a major solar storm and a significant software failure. While both are unlikely, the authors argue they are plausible enough to warrant serious preparation. Why this matters for everyone in space. These findings aren't just about Starlink. They apply to all maneuverable spacecraft operating in LEO. The authors urge policymakers, industry leaders, and mission planners to consider the crash clock as a real-time warning and to rethink how satellites are deployed and managed, starting immediately. They suggest that the current trajectory of dense constellations without robust debris mitigation could accelerate a dangerous tipping point in orbital congestion and debris growth. Discussion prompts. Do you think the benefits of dense megaconstellations justify the added collision risk, or should there be stricter limits and stronger debris mitigation standards? If the crash clock signals a real threat, what concrete policy measures or technological safeguards should be prioritized first? More robust debris removal, improved collision avoidance reliability, or better end-of-life disposal planning? How should space agencies balance rapid satellite deployment with long-term orbital sustainability, especially as new actors join LEO? In short, the study casts a stark picture: as low Earth orbit becomes more crowded, the margin for error shrinks. The question is no longer whether a collision will happen, but when, and what we do to prevent a cascade that could undermine the satellites we rely on every day.